We are skipping over chapter 5 because that is differential equations, and most of you are probably not going to deal with that. It's pretty fascinating. You can check it out if you want. But we are moving to applications of integration. This is actually really cool. So the example that they use in the book is an arch dam. And so basically you have these funky shapes, and we have to figure out how much volume there is to them, so that we can figure out how much material that we need. And so we use integration to figure that out, and we're going to use this chapter to learn how to do that with real life applications instead of just like sine or cosine and stuff like that. So today we are dealing with area of a region between two curves. So you have a curve like this and a curve like this. Let's say we want to find it from A to B, and so we are finding the area in here. So basically the way that we're going to go about this is you used to have from A to B, right? So let's say this is, let's call this f of x and this one g of x. So we're dealing with f of x, right? And to find all this area, we have to integrate it, right? So we're going to find all this area, but then we have this other curve coming in through like this. This is g of x. And so we want to get rid of this stuff so that all that we're left with is everything in here. So the way we're going to do that, you can find the equation on page 408. But basically we're going to take integration from A to B of f of x. And we're going to subtract it, or g of x, out like this. So basically we're just taking this whole thing and then we're subtracting out this. So now we're left with this. Trying to think of an analogy. It's kind of like, it's kind of dumb, but let's say we have a basketball hoop, right? And Jimmy is, so basketball hoop is 10 feet tall, right? Jimmy is 6 feet tall. And so Jimmy has to jump 4 feet in the air to reach, or for his head to hit the rim. We can find that by taking 10, the overall height, and subtracting 6, Jimmy's height, to find the difference, right? Draw it like this, I guess. And so that's the same thing we're doing here. And you already know how to integrate stuff. So that's generally what we're going to be doing. If you see a g of x equals 0, remember that is when we integrate that. So if we're integrating d of x equal to 0, this is just going to turn into a constant. A to B, A to B. So just keep that in mind. You'll run across that in a few of your problems. And let's do this. Oh yeah. So we sometimes will not have this boundary, right? And so it's just asking us to find the area between the two curves. So you're going to take the spots that they intersect, and that is your new A and B. So grab this, extend it all the way to here. So we're finding this whole area. So we're going from A to B. And so your A and your B are going to be where f of x equals g of x. Because this is where they share x comma y. The coordinate x, y, right? So for the same x, they will have the same y. And so you'll probably get 2 or more x values. So x1 will equal A and x2 will equal B. And then later in this chapter, we're going to deal with curves that intersect at more than 2 points. And that's basically just going to be adding to, so you're going to do this from A to B, and then from B to C, and then you're going to add those two together. But this is how you find it for, this is how you find your A and your B, or your interval for curves that intersect at certain points. Go ahead, walk through example 1, 2, and 3. I don't think I need to walk through these because you've already done all the same type of work. We're just now applying this equation to it, right? So we've integrated functions before, you're doing the same thing. And you can actually, yeah, if you need to, you can separate this out, right? You can just do integrate from A to B f of x, and then integrate from A to B g of x, and then subtract them. Yeah, so let me know if you have any questions or if you want to see me walk through any other problems.